we already started a little bit about this example here to illustrate how we can load data onto your computer memory and start manipulating the data for further analysis. Okay? And I provided the link to the data set. Let's click on the link and open it in a new window or new tab. And this is a CSV file hosted in one of my GitHub repositories. And you can see it's something like a table, right? The first line is basically the heading of the table. So those are the names of the columns for the table. And then starting from the second line, we'll have records. Right? In this table, in the CSV file, we actually have something about player information, given that we're going to have a couple of projects related to sports. So let's use a player example in a sports context. Now, if you have this CSV file, the next step is to load it, right? So that we can perform operations on it inside a Python environment. Now, what I'm going to do is that I'm going to right-click on the link to this CSV file, and then I will copy the link so that we can use the link to locate the file on my GitHub repository, and then we're going to load it, right? So I believe we just done it last time, but let's quickly do it again. So because we're going to use pandas library, we have to do this, importing the pandas library, and usually we call it PD as an alias. Once we have imported, and then we can load the CSV file. And the way we can load the CSV file is that we're going to do pd.read underline CSV. Because I have copied the link, as you can see, the AI assistant is already trying to help me complete the command. And the command is pretty simple. pd.readCSV followed by quotation marks inside the round brackets, and we provide the link to the file, right? So if the file is in your local computer, you just provide the file path to this command. And in this case, the file is in a remote place. We just provide the link, right? And now this function should help us convert the file into something called a data frame. We call it df for short. So the df is going to be the name of the data frame. And then once we run this command, the file will be converted into data frame, right? And then next, let's actually, in this bottom of the coding cell, let's just type the name of df, or if you want, you can say display df, and that will just help us view the content of the data frame, right? And this is something we have done last time, so let's click on this play icon to run the cell and to view the result. Now, what we're seeing here is exactly a data table. Nothing too different from a CSV file. It just sometimes it may give you a nicer structure, nicer format for viewing. Okay. Now, very quickly, I would like to mention this. So here, in the CSV file, we don't have too many lines. It means that we only have a limited number of records. Okay. So let me zoom out a little bit. As we can see, in total, we have 13 lines corresponding to the records of 13 players. For each player, we have their full name, their nationality, indicated by the country code. For example, AI should be Argentina, BR should be Brazil, and then we have the team of the corresponding player, right? So we don't have too many records here, only 12. But usually, when we are trying to view a large data set, there can be like hundreds or thousands, even tens of thousands of rows, or even more than that, right? It's not possible for us to fully display the content of the data frame on the screen. And in those cases, we still want to maybe peek a bit into the data set after we get the data frame, right? So remember, the data frame's name is df. So if I want to just preview the first few rows, we can use this command, df.head. The head function is a function attached to any data frame. So if you do df.head, it will show you the first, I believe, 5 rows. So let's run this command together. So as we can see, now we have first 5 rows, right? And on the left, as we may have also mentioned a little bit last time, we have the row indexes, right? So it all starts from number 0 by default. So row 1 is actually have the index equal to 0, and the second row is actually row index number 1, and so on and so forth, right? Now, not only you can have df.head, but you can also specify a certain number as the argument. For example, you can say df.head 6. So what do you think will happen? It will show us these first 6 rows instead of the first 5 rows, right? So it means that we can actually specify how many rows you want to see in your preview. You can also use df.tail. Very intuitively, of course, this is going to show you the last 6 rows in this data frame. Okay? So this is just some quick preview after loading the CSV file as a data frame. And once again, it's important that we observe this additional column on the very left. That's the indexes, right? Later on, as we'll see, this plays a big role in terms of how we can access the data records in a data frame. So any questions, comments? Now, what to do next? Right? Now we have loaded the data frame, we can preview it. In order to have some idea about the data, usually it's a good idea to see some summary statistics, right? Something that can describe the distributions of the numbers in the data and many other similar attributes with this data set. So this time, let me introduce another function. df is the name of the data set, and then we can do, first of all, we can do df.describe. That will give you some description of the big picture of this data set. Let's see how it will show us the something that may be important to have. The first step, you load the data set. So if you run df.describe, it will give you some summary statistics. As you can see, there are 3 columns. For each column, we get a count. For example, full name, it tells us there are 10 names. Right? And nationality, there are 13 values in the nationality column, and there are 13 values in the teams column. So question, why there are only 10 full names, whereas the values in the remaining 2 columns are 13? Why is that? Yes, please.
So the undefined.
Yes, it's exactly right. Because some of the values in this data frame is not sort of well defined. Right? As you can see, in the bottom 3 rows, the value for the full name column is actually NaN. I think we mentioned that very quickly last time. NaN in Python means not a number. Basically, it means that's not a valid value, right? Generally, you can consider those as missing values. For some reason, intentionally or unintentionally, for those 3 records, the player name is missing, right? Typically, it's some kind of error. Sometimes it's maybe for some intentional purpose, like protecting the privacy of the players, or sometimes it's a result of some internal operations in your programs. And we'll come back to that a bit later. Now, very quickly look at the remaining attributes provided by this function. Right? The second line shows you the unique values of every column. For full names, we have 10 values, and the unique value is also 10. Of course, it means that all those names are different. Right? However, for nationality, even though we have 13 values, but there are only 6 unique values, so there's some repetitive values, which is quickly observable. For example, we can see that there are a number of AR, a number of BR, like 3 PT values. So there's some repetitive values. Turns out unique values is only 6 instead of 13, right? And for team, the number of teams in total in this data frame is 8. Of course, this means that some players belong to the same team, right? And then the third line, it tells us about the value that appear the most in the corresponding columns. And then finally, it tells us about the frequency. Right? For example, the most frequent value for the name is this name, Diego Alvarez. Right? The frequency is just 1. I mean, actually, all those are unique values, so just to pick one of the values as the most frequent values, but they are actually equally frequent, so they just pick one, right? And then same thing for AR as the nationality appear 5 times. That's the most frequent value in row number 2, right? And River Plate as the team name appeared most frequently in the third column. So that's just some very quick summary statistics. Now, other than df.describe, there's another useful command which is called df.info. And let's see what it tells us very quickly. Now, as we can see here, it tells us about some information again about all those 3 columns. Right? So the first column, again, that's the column starting from the index 0, full name. It has 10 non-null values. Right? So I mean, NaN, the missing value, is not counted as a valid value. So these are not. Those are not counted. And other than missing values, we have 10 values for full names. Nationality, team, we have 13 values. So the most information about this df.info function will be that we just focus on how many valid values we have in each column. Other than that, we also know the data type of each column, right? So because here, all those values, they are basically textual values. So usually it is shown as objects by the info function. Anyways, that's a very first step to take a peek into the data frames you have just loaded. Now, the next thing that is also quite fundamental, I mean simple but fundamental, is that we need to often accessing and modifying the elements of the data frame. Okay? So let's quickly look at it. So the operations we're going to perform include maybe sometimes we want to get a column, maybe sometimes we want to get a row, or maybe sometimes we want to get a certain element, right? A certain value from the data frame. So let's perform several simple operations. First of all, we know that there are 3 columns, right? But sometimes for a very large data set, it is difficult to keep track of the column names by looking at the entire table. So one thing we can do is that let's only focus on the name of columns, right? So how many columns are there and what are the names of those columns? So this time we're gonna, for now, ignore the content of the data table. Instead, we're going to just focus on the column names. And this is pretty simple. df.columns. And it would return a list that shows all the names of the different columns. And let's run it. Okay. Actually, a quick correction. It's not entirely a list structure. Instead, it's an index structure because column names is considered some kind of index. Okay? So we can see there are 3 columns: full name, nationality, team. Okay? And you can easily convert it to a list if it is preferred. So you just put list and round brackets, parentheses, to contain this list, index of column names, and then run it again. We'll just get a clean list of all those column names. But anyways, indexes and lists, they are similar data structures serving similar purposes. And that's one task we want to do. Now, the second step, let's say now I care more about the content of the data frame, but not the whole thing, right? Let's say I'm only interested in the column of names. Let's forget about nationality, forget about the teams, but let's look at the names of all those players. How do we do that? And this time, first of all, again, type the name of the data frame. Here it's DF, right? Sometimes you have a different name. If you want to get a column, always use the square brackets. It's just like how you access the element of a list, right? And then inside the square brackets, you provide the column name. So full name is the column of interest for now, right? And then I run it, it returns the first column. So that's how we retrieve a column based on its name. Okay? You can similarly retrieve the second column by using df square brackets, quotation mark, nationality. So that's how we retrieve a column. And those are the basics, but then they're quite necessary in most of the analysis as a fundamental step. Okay? Now, what about we want to get 2 columns instead of just 1? Right? Sometimes we are interested in looking at or using a selected number of columns. We have 3 columns in this data frame, but let's say we care about full name and the team of the players for now. So we're going to get 2 columns. How do we do that? So first of all, df, the name of the data frame, and then square brackets for getting columns. Inside the square brackets, we need to provide a list of column names, right? So if we care about full name and team, those 2 columns will provide a list that contains those 2 string values, those 2 names of the columns. So remember that for lists, they are represented by values between square brackets, right? So I need to include another pair of square brackets. And then inside the second pair or inner pair of square brackets, we're going to provide the column names. Full name is the first column, and then team is the second column. Okay? So we have double square brackets, a nested structure of square brackets, and that's because the first square bracket is used for us to access columns, and the second square brackets define a list, right? So then if we do this and run this command, we'll see that we extracted the 2 columns we wanted, right? And nationality is not included because I didn't provide nationality as an element in the list inside the square brackets. Okay. And that's about accessing columns. Any questions? Okay, so next, after retrieving columns, let's do something about the elements and then also the rows. Right? So moving on, let's first quickly do df, and let's run this command just to view this data table again. Right? So question is that what about I want to get one of the element? For example, what about I want to get the name of the player in row 3. Right? Row 3 is the 4th row, meaning that we want to have the row of index 3. Okay? So what about we want to get this? If I know the location of this value, right? So the location of this value is going to be row index 3, and then focusing on the column of full name. Right? So just to quickly show this, what we want to do is that we want to use the indexes number 3 and also full name. So that helped me focus on a certain position in this table. Right? And then if we can use the row index and column name to retrieve it, then this is actually the target of this operation. Okay? So let's see how we can do it. Let me close this first. So if we are retrieving elements using both the row and column index, we don't just directly use square brackets. That's only for columns. Right? Instead, we can do DFD lock, meaning location. Okay? And then square brackets. Inside square brackets, I need to include two pieces of information. First of all, the row index. So I want this value in row number 3. So the first useful piece of information will be the row index 3. And then the second piece of information will be the column. And we want to get a name, right? So just include full name. Now we should be able to retrieve this name, Daniel Alvarez. And that actually indeed give us the desired result, right? So that's a quick way of retrieving values if you know the position. Other than using lock, location, you can also do at, I believe. So they are actually the same kind of operation that gives you the same result. It's the same, no difference, right? However, even though df.add and df.lock, they give you the same result if you focus on one single element in the table. Sometimes you may want to get several elements. Right? So let me quickly explain. So to do that, let me go back to the data frame content. Now let's say this time I want to do a bit more than just retrieving one element. So how about we retrieve at the same time several elements, right? So for example, let's say I want to get this person, Diego Alvarez, and his team name. Okay? At the same time, let's also get the next record, D Alvarez. Let's also focus on the team. How about if we want to retrieve those 4 values, right? So it means that I care about 2 players. I want to get the name and their team. So how do we do that? So let's change our code slightly. Now observe that we want to get information from row 1 and row 2, right? So again, we need to do df.lock. But then instead of providing a single row index, let's provide a list of 2 row indices. Okay? So 1 and 2. That's the first part inside the square bracket to show you which rows we want to focus on. You can provide only a single value. It means that you're only focusing on 1 row, or alternatively, like what I'm doing here, we're focusing on 2 rows, right? Row 1 and row 2. Same thing for the columns, right? So this time I need to provide 2 columns. First of all, full name. And then let's also get the team values, team names. Right? So this is how we retrieve multiple values. Sometimes this is called slicing, right? Because we are cutting off 2 rows, and then we further slice off 2 columns from those 2 rows. Right? So the idea is pretty much the same, but we don't provide a single row index or a single column name. We provide a list of row indexes and a list of column names. And let's look at the result. It looks like it indeed gave us what we wanted. Okay? Questions for that? All right, so moving on. Now, we want to get 4 rows. What we did is to get elements or slicing certain rows and then certain columns out of the data frame. But let's get the four rows. Right? I only want to get 1 row, or maybe get a few rows. Right? So let's start from retrieving row number 1, row of the index 1. So df, again this time we can do df.lock. And what we can do is actually just to put 1 inside the square bracket. I mean, you can do 1, comma, and then column. Column means from beginning to end, right? If you typically you have a previously we mentioned that you provide a start index, let's say starting from 0 and ending from 3, because it goes from 0, 1, and 2, stopping before reaching 3, right? But then if from beginning to end, you can just use column, and or you can even omit the second part. Let's actually test it out, okay? So if we do this, as we can see, it's a row, even though it looks like a column, but then it just show you in a vertical way, right? It's actually a row. Full name, nationality, team, that's 3 attributes of this row. Or I can just do df.lock 1, same result, right? So that's how you retrieve columns. And you don't need to just retrieve 1 column. You can do inside df lock square bracket, you can do 1 and 2, a list, right? So that will give you 2 rows. If you want, you can do comma following the row indexes and put column, and that means that in terms of the columns, go from beginning to end. Okay, and it should give you exactly the same results. And that's 2 rows, right? Row number 1, row number 2. Anyways, those are several different ways for retrieving rows from the index. Okay. Now, those are basic operations, but sometimes can be useful if you are, enumerating over the different elements, and sometimes you need to, first enumerate over the possible indexes, right? And once you get an index, retrieve the corresponding value. Anyways, perhaps one more, somehow more useful operation is to set a condition and retrieve values or records based on this condition. Right? So here, this is some command we're going to run, right? So provide the name of the data frame and square bracket. Inside square bracket, this time we don't provide column names or indexes. And this time, what we want to do is to provide a condition. And let's look at a specific example, right? So this time we want to select rows where the player's nationality is ES. I suppose that ES is actually, well, actually we don't have ES in the nationality, so let me change it slightly. Maybe change it to AR, right? So whoever is from Argentina will be selected. And that's how we do this. First of all, remember we have to define a condition, right? And how do we define the condition? Well, let's do this. df and quotation marks, then nationality. Right, that will give us the column of nationality in all the data records. Okay. Now, what I want to do is to check if nationality is equal to AR, right? So double equality mark, and that means checking if this condition is this equality is true or not, right? If you only have 1 equality mark, it's actually assignment in Python, assigning a value to a variable. That's 1 equality mark. And 2 equality marks in Python and many other programming languages, that means that you're checking a condition, whether the equality is true or not. So equal to AR. Okay. So what do you think it will return us? This nationality column equal to AR. Right? The nationality column, of course, contain those 13 values of I think 8 or I guess six different nationalities, right? So let me run this command and we can view it together. And turns out I believe this is somehow quite intuitive. It's a column, right? Because df nationality is a column. Then after I impose this condition, as we can see, it checks whether or not the condition is satisfied by each row, right? So row number 0, if you remember from the previous original data frame, it's actually AR. So it's satisfied, right? The condition is met, so it's true. The second row, row number 1, also true. But then for starting from row number 5, until the end of the data frame, as we can see, it's all false, right? Because those nationality values for those remaining data records, they are not equal to AR, right? So this condition is checked for every record, right? That's the meaning of df nationality equal to AR as a condition. Now, this is not our ultimate goal for this example. What we want to do is to select all those records for which the nationality is equal to AR. In other words, for those rows where the condition is found to be true, right? So we're going to do this. This is our condition. Let me maybe cut it so I can use it later. So then we're going to do df and then square brackets. Okay? Now, if we just type in the name of the column, it retrieves the column. But now we don't want to retrieve the column. Instead, we want to select based on the condition. So I'm going to just do Command V to paste the condition expression in between the square brackets, right? So that will help us retrieve the records that satisfy the given condition, which is that for the value in the column of nationality, it should be equal to AR. And then if you look at this intermediate result, all those rows with true values will be selected, which is row 0 to row 4. And let's try to see. And that should be looks like indeed the case, right? So we see that now we only have part of the data frame, which is row 0 to row 4. And what's unique to those rows is that the nationality value is equal to AR. And that's how we select records. Questions? Okay, so we're going to just go a bit further for selecting rows based on conditions, right? So let's make it slightly complicated. For example, sometimes I want to select records that has the nationality being AR, and then I only want to further select those records on the team, let's say racing club. Okay, so this time we have two conditions instead of one, and how do we do this? So let's see. So we can do this. We can write down the condition one by one. All right. So the way we can do this is that we can do df nationality equal to AR. That's one condition, but that's not enough. Now we have a second condition. Let's say in the meantime, we also need to satisfy second condition, which is that df team is equal to, the hint says River Plate, but let's do Racing Club. Okay, so it's sort of simple, right? We just put the two conditions together by this AND sign, so mean that it's a joint condition. Let's quickly run it. I think it's I guess it doesn't work that way. I need to include it in an expression of selecting conditions inside the data frame. Okay, so what we can do is that we can put df data frame name and square brackets. Inside this pair of square brackets, I provide two conditions. And let's see, it is going to work this time. Still not working. Just give me a moment.
I think you need brackets around
Uh-huh.
around the end state.
Sorry. Is it the bracket?
Like a regular bracket around like each parameter of the end state.
Oh, this one?
No, like if you like around like two. Okay, wait, I don't know how to describe. Like wait, go
Uh-huh.
to the left
Okay.
and then bracket.
Yeah.
No, like a regular bracket.
Uh,
So like the two parts of the ends we have
No, like,
DF.
Oh, okay, okay.
DR, that in bracket and the other
Yeah.
part.
Oh yeah, so sorry. Yeah, right. So I forgot about this. Yeah, so that's my bad. Yeah, there's a useful feature about by Colab. I can say explain error. And sometimes you make an error. Sometimes sometimes it's difficult to figure out immediately. Okay, so then it actually try to help me fix the error. We can see it actually look at the green line, which is the code generated by Gemini based on my code. So I had this little error, and then let's say accept and run. Okay, now that's fixed, right? Thank you very much. So that's my bad. So forgot about the syntax of this sorts of things. But anyways, so if you make small error, I think with this all AI features, it's these days very easy to fix, right? Now that's one thing we can do to select records based on two conditions, or maybe we can do this. Okay, maybe we can replace the and symbol by this separation symbol. Right? It means either or, right? So this time I will select conditions, either the nationality is AR or the team is racing club. Okay, so let's see how it goes. Okay, so now this is the result. As we can see, all those records with nationality equal to AR is selected. But actually this is a coincidence, right? So if we have a team, have a player whose nationality is AR and the team is equal to, So if I have a player, nationality is not AI, but team turns out to be racing club, it's also included. It just happened that in this case, we don't have such a player, right? Now, all those teams, either the value is racing club, they're included, or they have a different team, but the nationality is AR, they're also included because we have an either or condition, right? So I think you can join more than two conditions. You can use three or more. The expression should be similar. We can leave you to do some experimentation after today's class. Okay, but now do we have any questions? All right, so let's move on. Now, before we have the break, let's quickly move on to several other important fundamental operations. Right? For example, sometimes I may want to add a new column, delete a new column, or add a new row, or delete a new row. Right? So let's do a bit more experimentation. Right? For example, now let's say I want to add a new column called age. I want to record the player's age in the data set. Okay, so what I can do is simple. So df age, and that means we are retrieving a column. But then the tricky thing is that age column did not exist. Right? It doesn't exist in the original data frame. So if you just do df age, it will give you an error. Right? However, if you are assigning values to this df you will get a new column, right? So if you're assigning a list of values to a column, then you will get a new column. So we have 13 rows in the original data frame df, so we have to provide a list of 13 values. So every player, every row gets a value for the new column, right? So let's do this. Let's do this assignment, and then in the end, let me type the name of the data frame, and then we can run it. And we can see now we have a new column, right? Which is age. And the values of this column is precisely the values I provided in the list, right? So that's how you get a new column. If, let's say, you don't know, let's say you don't know the values yet, you can, I think you can use df age equal to none. So let me see if it's working or not. Yeah, so if you're not sure, you can just assign some unknown value represented by none, and that's and then later on when you know the ages, you can fill them in, right? And then if we can add a column, let's also quickly test how to drop a column, right? So now we have this new column called df, called age, right? So now I want to drop this column. So let's do this. df.drop. And then in this function, you are going to include, you're going to provide all those columns you want to drop. So columns equal to, let's say here, right now, we are only dropping one column. If you want to drop several columns, you can provide a list of multiple columns. But now it's a list of only one column, right? So let's do this. And then you see the age column is gone, okay? However, let me show you quickly one thing. After dropping, let me type df to show the content of the data frame again. You will see that the age column is still there. So why is that? So let's comment this out. And we see that indeed we have dropped the column. But then if we include df to show its content, you see that the last column age is still there. So looks like we have dropped, but we didn't drop anything. So why is that? Any guess? Yes, please.
You have to save it to the data frame?
Say that again.
You have to save it to override the data frame?
Exactly, right? Because if we do this, we actually didn't change the data frame. What it does is to return a data frame with the age column removed. It's not the original data frame, right? It's a copy of the original data frame that has the additional column removed, right? It's not the original data frame. So we can do two things. Either you can do some overriding to assign the value back to df. Now, the original df data frame is overwritten by the new value, or depends on what you prefer. Or you can just inside this function you can say in place equals true. It means that I want to make the change inside the original data frame, right? So let's run it again. Now it's really gone, right? So the age column is really gone. Perhaps let's do one more thing before we have today's first break. Okay? Now we talked about how to add columns, how to drop columns. This time let's see how we can add a row, right? So it's actually quite simple, right? So because we do know that how to retrieve a row based on index. So we can just set a new index and assign values to this new index. Okay. For this data frame, we have 3 columns, so you just assign 3 values corresponding to the 3 columns to a new index. Slightly tricky, not very tricky, but slightly tricky is that typically we don't want to have repetitive indexes, right? So if you say df dot 2 equal to those values, it's slightly problematic, right? Because in the original data frame, there's already an index 2 for a row, right? If you do this, I don't think it will give you any errors. It's just that you will have 2 rows with the index 2, which is not very convenient. Sometimes leads to possible errors. So whenever you are retrieving row index 2, it gives you 2 columns. Right? It's not very convenient. So let's try to figure out a usable index, right? So let's say I want to get a new row index. So what do we set that to? So before that, actually, let me cut it. So let's say df dot index. I mean, we have seen df dot columns. That give us all the column names. df dot index will give us all those indexes, right? We can convert it to a list to better visualize it. So we will see that it's actually from 0 to 12. That's all the indexing in the data frame. Let's remove this. What I want to do is that df.index, and then I do this function for this df.index, which is to return the maximum value of all those indexes, right? Let's see. It's 12, right? Because we have indexes from 0 to 12. Right? Now, let me add 1 to this maximum index. Now it's 13, right? And then I will assign this value 13 to the new index. And that makes sure that we will not have any redundancy, right? We don't have any repetitive value. So let's look at, of course, if we show the value of new index, it will be 13. Okay. Now I can do df.log, which is for manipulating rows. New index. I mean, this will give you error if you stop here because there's no row of index 13. But if I do assignment, that is okay, right? So let me assign 3 values. Let's say Anna Martins. Nationality is PT. And the third column value is, let's say, Benfica as the team name. Okay. Now we can look at df. And in the bottom, we have a new row of index 13 that's somehow intentional. I mean, if you want, you can set 14 as long as there's no conflict. It doesn't have to be continuous. Now, we have 3 values, Anna Martins, PT as the nationality, and Benfica as the team. Okay, so that's how we add a new row. Now, the next step is that we want to actually drop a row. And drop row, somehow it's easier. And let's quickly see how we can do that, right? So let's say I want to drop the row of index 12. Okay, quickly going back, the row with index 12 is a row with a missing value for the player name. And once you have the index, it's pretty easy to drop. So it's going to be df, that's the data frame name. And then we do drop. As you can see, the AI assistant is already suggesting what we are going to do, right? So it's quite easy. Just provide the index of the row to be dropped, right? Index equal to 12, and then specify in place equal to true, so that we are directly modifying the data frame. So let's run it. And here is the data frame again. As we can see, index 12 is done, right, because we dropped that row. It doesn't really change the indexes automatically. So we see that even though we started from a continuous set of indexes, after dropping a row, it becomes discontinuous. Right? So that's how we can quickly drop the row. Sometimes you may feel that, okay, so it doesn't look nice if the indexes are not continuous, right? If that is the case, you can just use a reset index method to reset the index of the data frame. Okay, so we can do df dot reset index using the codes hinted by the AI assistant. We can make 2 observations here. Right? We have something we call the keyword arguments for a function, which is some attribute equal to a certain value. In place equal to true, that's somehow understandable, right? Because we want to directly modify the original data frame. We want to modify the indexes to make them continuous, but then we want to make the change directly in the original data frame. But what is drop equal to true? Okay? Drop equal to true means that I'm going to drop the original indexes. It was from 0 until 10, 11, and then jump to 13 because we dropped index 12, right? If you don't specify drop equal to true, then you will get another set of indexes in the very left, so from 0 to 12. But then you still keep the second set of indexes, which may be somehow confusing in most of the time. So we specify drop equal to true. So we drop the old index and add a new index, which is continuous. Okay, so let's just run it. And we see that this time the rows are indexed from 0 until 12. It was record 13 for the last row, but now it's actually record 12 after we reset the index. Okay, the purpose is pretty simple, just to make it look nicer. Okay, and later on, let's say if we are doing some iteration using the indexes, and then it's easier for you to write codes because you can, every time you want to go to the next record, you just increase your index by 1 if the indexes are continuous. Okay, questions? Now, we have done a bunch of operations on the data frame. We loaded from CSV file, right? Now, one thing we want to do, sometimes at the end of several operations, we want to save the data frame. Because the data frame was from a CSV file, but you modified it, and then it lives in your computer memory, right? If you close this Colab notebook, or you got disconnected by Google after a certain period of timeout, you lose everything, right? It's not going to be saved. So a safer way is to save it as a CSV file, and then we can download that new file. Okay, let's quickly do that. So the way to save a data frame as a file so that we can permanently keep it is simple. So data frame name, because that's the df is the data frame I want to use, and then .toCSV, that's gonna save the file as a CSV file, right? And let me just specify the arguments. So first of all, I would need to provide an argument that is the name of the CSV file, right? So originally, if you remember, it was players.csv, but to differentiate, let's do players revised.csv. Okay? And you could do that and run the command, it will give you a CSV file. But usually there's something we want to do. Let me first type it and explain. Typically we want to use index equal to false. What does that mean? So let's quickly go back to this table, right? So what we want to save is the 3 columns for all the records, right? Typically we don't want to save the index on the very left, right? Because that's something automatically generated by pandas. And next time I load the CSV file, they will create, the pandas library will create another new set of indexes for me, typically from 0 until the last record, right? So if you don't say index equal to false, by default, you will have a table where the first column is the indexes. Right? But typically, that's not very informative. So I will drop the indexes from the CSV file I want to generate. I only want to focus on the 3 rows, which is the real content of the data set. So that's why I specified index equal to false. I mean, you can do some experiments. If you don't specify index equal to false, you can still get a CSV file, but you get the index column in your CSV file, which typically is not that necessary unless you have a specific purpose. Okay, so let's run it, and there's no error. That's great, but because we're running codes on Colab, this creates a little bit of a complexity, right? Because if you run this command to save the CSV file locally on your computer, you will just find the CSV file in the same folder as the location of your Python notebook. But it's in the cloud, right? So where do I find it? It's saved, it's there, but where is it? Now, to quickly visualize, go to Colab. There's a site panel, right? And this icon has there's an icon of file or a folder, right? Click on it. And then we can see this is actually the default directory on the remote server that contains all the information we're using related to this notebook. Right? As we can see, players revised.csv is right here. What you can do is that you click the three dots on the right and click on download. You can get the CSV file on your computer. Okay. Or alternatively, let me do this quickly. Let me make it full screen. So you can also do it by commands. You can do it from google.colab import files. So there's a module called files inside a library created by Google called google.colab. That allows you to manipulate your files on the server. Okay, so then I can do files, that's the module imported from the Colab library by Google, files.download, and what do I download? I provide the name of the CSV file, right? So let's run this command, and then it just downloads another copy of the same file. So it should be in my downloads folder. I mean, it's always the default folder where you set to contain your new downloads, right? So let me open this quickly. Let me open it by Excel so that we can quickly visualize it. As you can see, it's exactly the pandas data frame after our operations, right? We have two missing values. In the beginning, we have 3, but we dropped 1 row, so we have 2 missing values. And then the last row is something I added in one of the operations. I added a new row at some time point, if you remember. So that basically concludes the most fundamental kind of operations regarding pandas, how to use pandas to load data, do some retrieval of the data elements, and also do some modification. Right? And finally, typically want to save it back because otherwise it's computer memory, and in this case it's actually in the server's computer memory. It's going to be lost if you don't save it and download it. Okay. So that's about the basic operations for pandas.